I am Devansh Dhutia. I am a platform architect at Gannett. For those of you that may not have heard of Gannett, it's a large newspaper media publishing company. We have a market presence of about 92 plus local markets, and just the other week, Gannett acquired another publishing company. I think it's called Journal Media Group. So that adds another 16 or 20 papers to our portfolio. We have one national brand, which is USA Today, that some of you probably have heard of. And then there are some other regional papers that are pretty large markets, like the AZ Central newspaper, Detroit Free Press, Indianapolis Star, and so on and so on. So I'm going to jump a little bit into our architecture slide because I wanted to highlight what those numbers actually mean. Today, Gannett is hosting all of the content on a single platform for all these papers' content, right? Our CMS drives all of this. We have a digital-first policy, so our editors will come in and create content in the digital platform first, and then it goes to the actual print. And this was a recent adoption. We've been moving towards the digital-first policy for the past, I want to say, 2 years or so. And this sort of is a very high-level peek at the architecture. A lot of elements sort of have been stripped out to make it fit here even. And Solr plays a very big part of this picture, and I'll go into that a little bit. But what this also shows is where our platform is headed. Just because we have all 90 plus markets on one platform, we're not done. We're constantly evolving it, we're changing it, looking forward. So what are we going to talk about today? We're going to look at what Solr means at Gannett. We're going to look at current state of affairs with Solr. We're going to look at some creative uses of collection management. We'll look at some problems that we've been seeing with indexing and how we're proposing to fix that with a queuing solution. And there's some future work that we're also outlining, and hopefully time allows, we'll take some questions. So Solr at Gannett. Today, we're hosting about 20 million plus documents. When I submitted the proposal for the talk, we were at close to 16 million, I think, if I recall correctly. And we're growing at a rate of about 800,000 documents per month. And this is not 800,000 news stories per month. This is 800,000 what we call assets. So they're news stories, they're video documents, they're images, all sorts of other associated metadata that goes with these stories. Our Solr cloud is highly available. During peaks, we're serving about 100,000 requests per minute. Most of these are queries. Our write volume, when we're not doing the batch indexing, our write volume is rather low. It's in the thousands of writes per hour. When that volume is generated basically from the editors creating and updating stories. It's extremely fast. Most of those requests that you see up there are served in under 100 milliseconds or so. There's 40 plus applications that use our Solr cloud infrastructure, and that's just going to grow as we go forward, as we introduce Solr cloud into our various other applications. And our Solr cloud infrastructure is comprised of 8 nodes. Each node is about 32 gigabytes of RAM, so that's 256 gigabytes total. I don't know why the CPU stats aren't on there, but it's quad-core 2.2 gigahertz processors. So here's what it looks like today. We have an authoring API. That's where the CMS, ingestion engines, feeds, all those content generation tools will post documents or changes to. Those get stored into a persistent store, and that same authoring API is responsible for sending a call to our indexing service to tell it that here's an asset that changed or was created, so update Solr. That indexing API then takes the document from our database, transforms it into a Solr document, and posts it to the Solr cloud that's in its own data center, but it'll also go ahead and post it to the opposite data center. We have one data center in the east and one data center in the west. So our indexing API today is what's keeping the two Solr clouds in sync. So that's sort of our makeshift cross-data center replication. And then we also have a batch indexer tool, which allows us to index a subset of data or the entire corpus if there's a data change in the database that needs to be propagated to Solr in bulk. And then we also have a search API, which is the gate into Solr. We enforce some ACLs, we enforce some query validation. So all of that has to go through the search API. Nobody has access to Solr directly. And then the same thing happens in the opposite data center. Any writes that go there will be written to this data center.
Is the persistent store also replicated?
Yes, it is. Yes, yeah. The database has its own replication scheme. I just didn't have that line between the two. Yep. Thank you. Thank you for bringing that up. So current state. As you clearly saw from the previous picture, everything is a synchronous operation. The same thread that's creating the story or changing the story saves it to the database, sends it to the indexing service, and all of that is all done in a single continuous flow. If any one of those steps breaks down, the entire flow breaks. We have some pretty near real-time requirements. So our editors expect that when a story is created, it'll pop up in their CMS dashboards within seconds. Our CMS dashboard is largely driven by Solr, so they expect content to come in pretty quick as soon as it's created. A problem we have with this sort of setup is our schema changes are very time-consuming. Our indexing tool isn't the fastest. I'll be the first to admit that. And so we've tried to take steps to work around that and mitigate that, and I'll show you how we're doing that. But the other bigger issue is when there's a Solr cloud outage, the impact or the fallout from it is highly visible. It bubbles up all the way to the CMS, and it leads to a lot of frustration. So we'll look at the first issue first. Long time to do schema changes. What we are doing is we will prep an alternate collection. So when a developer says, hey, we need a new field index or something, we'll go through our review process. We'll get the schema change into master. Once it's there, we'll prep a new collection. All our collections are numbered. So today we're on assets 10. Schema change comes in. We're on assets 11. Excuse me. Schema change comes in. We go to assets 11. We'll deploy the vNext of our batch indexer, because that's the one that knows what to do with this new field. And we'll have the new batch indexer prep all the data from the database into the assets or document 11. Once that's done, we have an alias in Solr that points to which one is the currently live collection. We just update the alias to the new collection, and we deploy our indexing and search applications. And everybody is now on the new collection. There's a gap between when we create the new collection and when we complete that indexing process. It could take hours. Sometimes if there are issues, it could take a day and a half. So there's content that was still created in that time. So when the alias is updated to the new collection, we run a quick catch-up to get that missing window of data that might have been created or changed. So our new collection is current. Here's how that visually works. We always have, everybody goes and talks to an alias. Nobody talks to a collection directly. The alias always points to the currently live collection. And then we have the one version back as a backup. When there's a schema change, we create n+1, which in our current example is assets 11. We'll deploy the vnext of our batch indexer and ship off all the data to it. The nice thing with this is it can sort of run at its own pace. We do need a little bit of a lead time when we have schema changes. We can't deploy a schema change tomorrow. We sort of have to prep for it. So this allows us to do that. And then when the schema is ready with the new collection, update the alias, deploy code, run the catch-up, and drop the 2 collections ago version. This way, we always have one version behind as a backup in case we have to do a rollback. This way, we're also not flooding the live collection with a whole bunch of indexing activity and causing commits, soft commits, drop our caches all the time. Can we save them for later? Okay. That helps us with our slow schema changes for now. We want to make it even faster and better. But with that, when we have an outage, we have, like I said earlier, very frustrated editors. The CMS seems to lock up on them. When Solr goes down, the endpoints that are responsible to talk to Solr start timing out. So they have retry logic in it, so they keep retrying. And that entire process adds about 45 to 60 seconds to a save. When that happens, the editors think, oh, my story didn't save. Maybe I'll go back in and save it again. But it might already have saved to the database. So now they're creating duplicate content. And so we have to go back and clean all that up once we fix the outage. And sometimes they can't find new content. So then they go and create it again. And then this also, obviously, when Solr is down, our UX and presentation layers are impacted. So how do we solve this? We will solve it with asynchronous write operations. We're going to use a queue-based solution called RabbitMQ. We are still going to maintain our near real-time requirements. We don't want to change that. We want content to show up as fast as possible. With the new paradigm, we also want to be able to auto-scale our indexing workers. Today, we run 2 services that do all of our batch indexing. We'd like to scale that out so that if RabbitMQ gets flooded, spawn 10 more and process it even faster. We'd like to lower the authoring outage impact. What do I mean by that? When Solr Cloud is down, the document isn't going to get written to Solr Cloud. I mean, there's no going around that. So the editor still probably won't be able to find it in their dashboard. However, we'll be able to at least present them with a faster response. We'll be able to tell them that their document was saved, but maybe not indexed, so it may not show up in your dashboard for a little bit. That's sort of propagating that outage issue up to the CMS. And we'll also end up with an eventually consistent model. OK, so Solr Cloud is down. Your asset didn't index, but it will eventually index because it made it to the queue. And we'll see that in just a second. Right here. So similar to our previous picture, with the exception of no more indexing API, the authoring engine will just write a document to RabbitMQ. And then we'll have 2 sets of services. We'll have an indexing service, which is whatever is currently live. It'll pick messages off of RabbitMQ, prepare the Solr document, and write it to Solr. If Solr is unavailable, we can shut the indexing workers down or just let them ignore the failure and put the message back on the queue. If it can't write successfully to the queue, it can put it back on the queue, and it can have retry logic, whatever complexities we'd want to add there, we can add there. We would also have a similar indexing service, which with the vnext version, so we can do that same alternate collection preparation, which would have a batch push application that puts IDs on RabbitMQ. Those IDs would only go to the one that's in prep mode. And I'll show you those steps as well, because we want to maintain the alternate collection indexing. And previously, we were maintaining our cross data center rights. Now, we offload that responsibility to RabbitMQ and let it shovel the messages back and forth. For those of you that are not familiar with RabbitMQ, it is a clustered, highly available queuing solution. You can spin up 5 or 6 RabbitMQ nodes. You can set up all your queues on them. You can have the queues replicated, so it is fault tolerant as well. It's a first in, first out model, so everything will be processed in order. You have to have publishers and subscribers. Your content generators will be your publishers, and your subscribers will be the indexing services. I'll show you what consistent hash and multiple queues are. The next slide. So when a publisher generates content, it will put a message on an exchange. The exchange is responsible for routing the message to the right queue. Think of it as sharding, but for queues, right? With Solr sharding, you put a document on any shard. It'll route it to the appropriate shard based on the unique key. And then you'll have your subscribers watch all those queues and know what to do with each queue. So what are the queues that we need for this? We have a real-time queue, which is where all the current CMS changes would go. So saves, creates, updates, deletes, all that. We have a batch queue, which will allow us to put messages on for batch operations when we have data changes in the database. We still want to be able to index things in bulk. Real-time and batch queue will only be consumed by the live indexing service, and it will only write to the currently live alias. And then we have a prep queue. The prep queue is where we would flood the queue with all our documents when we have to prepare a new collection. This queue will only be monitored by the indexing service that's in prep mode, so the next version that's running. And then we have a dead letter queue. Remember earlier when I talked about you can have whatever complexities in your indexing service for failures? Dead lettering is a concept in RabbitMQ where if you are tired of retrying a message, or if you know a message will not succeed, you have the option to dead letter it. That means put the message onto a different queue for further analysis later. You can choose to just throw the message away and say, yeah, it's all good, I'm done. But if you put it on a different queue, you can have a different process, be it automated or manual, take a look through those messages and see trends in your failures. You can analyze why things are failing when they're failing. You can spot, times of day when you have more failures or less. And then we obviously have our new indexing service, which needs to run in 2 modes, live and prep. When it's in prep mode, it just watches the prep queue. When it's live, it watches your real-time and your batch queues. And then we have the batch push service, which is responsible for putting your bulk messages on your queue. Future work on this that we've identified, at least for now, we'd like to do continuous delivery of our schema. We're treating Solr configuration as code. Everything goes through a repository. Everything goes through a peer review process. And once it's in master, we wanted to deploy automatically, create a new collection automatically, set up vNext if it's available automatically, start that indexing already. We'd like to build the Solr payload in one zone only. With the current queuing solution, we're having to build it in 2 places. We'd like to avoid that and reduce cycles and just do it in one zone and then have it posted to 2 places. We'd like to have automated dead letter handling. So there's some messages that you can safely retry after Solr is back up from its outage. So we'd like to have that happen automatically. and we want earlier notification of potential failures. So today we have plenty of monitoring around Solr Cloud, but we don't know about an outage until maybe a few seconds before or as it happens. Right? There's very little warning or lead time that tells us there's going to be an outage. We'd like to have some additional monitoring of this is a research item for us, additional monitoring that will tell us a failure may occur earlier. So be it high traffic trends that are going up, be it more aggressive memory watching. So there's a number of things that our teams are looking into for identifying those sort of key triggers for when things are going to go south. If it's a sudden spike, you go from 10 users to 10 million in a second, there's no predicting that. So there's always going to be those sudden failures that you might come across. That is my talk. If you guys, Gannett is always hiring. If you guys are into Couchbase, Solr, NoSQL databases, Node.js, please hit up our website or come talk to Eob or myself. We'll be more than happy to talk to you.